circle, reflections, and then a few that deal with graphs and reflections of graphs. Okay, the first question says the number pi over 4, well, that's an angle, and that angle will be over here, right about there. Determine the point on the unit circle, right, that point right there, which is root 2 over 2 and root 2 over 2. And the question says, what are the coordinates of the point determined by minus pi over 4? Well, minus pi over 4, instead of being an angle that goes up, that's pi over 4, would be an angle that goes down. So that's this one right there. And so this angle is minus pi over 4. And they want to know what that point is. Well, the point, since the angle, the reference angles are both the same, the point has to be the same thing. Or the ratios have to be the same. It's just that maybe one of the signs has to be different. The x value is going to stay positive, just like this one, because it's to the right of the origin. But the y value, this one goes up, so the y value is positive. This one's going down, so the y value has to be negative. So that would be the coordinates of the new point. Here's another sort of similar question. They say the number b, or an angle, beta, determines the point on the unit circle with the coordinates negative 2/3 and 5/3. So negative 2/3 is going to be to the left, and 5/3 is going to be up. So the point has to be somewhere, it's got to be in that quadrant. So negative 2/3 and root 5 over 3. And we don't really know what that angle is, or we don't know what this reference angle, but it doesn't really matter. Then they say, what are the coordinates of the point determined by minus b? So if I, instead of going up to get to that angle, if I have to go down, I have to go by the same amount. So that point there and this point here would be, I guess they'd be reflections on the x-axis. But this would be the angle minus b. So that point, again, it has to have the same coordinates, or same ratio, 2/3 and root 3 over 3. But then because it's to the left of the origin, x is negative, and because it's below the origin, y has to be negative. Okay, so those 2 points are reflections on the x-axis. Okay, the next couple of questions deal with trig functions. So they say sketch a graph of y equals sine theta. Okay, sine theta always starts here, and it ends here. Now, and it crosses through a pi, and it reaches a maximum at pi over 2, and a minimum at 3 pi over 2. So the graph looks like this. Okay, so that's your basic sine graph. Then they say, by reflecting the graph, sketch a graph of y equals sine minus x. So this one, if you're looking at transformations, that's a b value, and that reflects things on the y-axis. So instead of going up and to the right, this graph would start at the same spot, but it's going to go up to the left, and down, and down, and up. So that graph would look like that. Now, I could continue that graph and keep going, and it would just be a reflection, which sort of seems a little funny. It'd be a reflection on the, it looks like it's a reflection on the x-axis, but that minus tells me to reflect on the y-axis. Okay, so that goes through. And then they say, by reflecting the graph in part A, so this one, sketch a graph of that, where it does reflect on the x-axis. So, again, I would start here, but this minus tells me to reflect on the x-axis. So instead of going up like that graph does, I have to go down. And I would do the same thing, and so it would be the exact same graph, which is sort of funny. This graph and this graph would be the exact same ones. And that's what they're asking in the last question. Okay, next question. Let's sketch another one. Okay, we're sketching sine x again. So I gotta go up to there, down to there, down to there, up to there. So up, down, and up. Okay, now they want me to sketch a graph of this. So I'm gonna, the plus there, so I'm gonna go left by pi. So instead of starting here, I gotta start left by pi. So here's pi, so I'm starting here. So I'm going to reach a top there, come down through here, reach a bottom there, and stop there. So up, down, and there. So when you look at those two graphs, the one is left of the other one by pi. Then they say, by reflecting the one in this one, sketch the graph of y equals minus sine theta. Okay? So minus sine theta, that minus means reflect on the x-axis. So the normal graph goes up there, so this one is going to go down there. Hold on. It's going to be the same graph as that graph and this graph are going to be, again, they're on the same trajectory. That red one would just continue on forever, and the green one would continue on again forever in the same path. Okay, the last question I think is probably the same thing, but it's a close graph, so it's worth taking a different look at. So a close graph, the normal one starts here, goes down through there, bottom there, up through there, reaches its top again there. So it's going to be like this, something like that. And it would keep going on with that same path that way, and it might as well go back to the left too. So it would go down, and then back up, like that. So it would have a little bump there. So that's a normal close graph. Then they say, go left by pi. So instead of starting here, I start left at pi. So I start there. So I'm going to go down, and then back up to there. So I just took this portion here. I just took that portion there and moved it left by pi. Then they say reflect the graph, this one, so this says reflect on the x-axis. So instead of starting here, I'm going to start down at minus 1. Okay, it's going to be the same thing again. And so the graph will come up through there, and down through there, and it'll just keep doing that same thing. So those graphs, again, if I went that way, those graphs again would be the same. These two graphs would be the same. Okay, so I'll help you with some of the graphing. I find that if I can graph things on decimals or a graphing calculator, I can quickly sort of see what the graphs are doing and that they're the same thing or what kind of transformations are happening.